Hello and welcome class. So in last class we were continuing the chapter number 7 motion of class 9th NCRT and we were learning about the topic graphical representation of motion, and in last class I have explained you the graph between distance and time. So we were understanding this case where on x-axis is the time axis and the scale was second, and in y-axis is our distance and our scale was in meter. And we have learned that in uniform motion, the curve of distance time graph is a straight line. So we were considering a region AB and we drawed a parallel line along y-axis and a parallel line along x-axis. And where these two lines intersect, this point is our C point. Okay. This point is T1, this point is T2. This distance is S1 and this distance is S2. So if I talk about what is the length of AC in time scale, the length of AC is T2 minus T1. So AC is T2 minus T1. And what is the length of BC? BC is S2 minus S1, and the slope or the line AB will be described as S2 minus S1 divided by T2 minus T1, which is our speed V. So distance time graph represent speed, and how it represents speed? It represents speed by this formula S2 minus S1 divided by T2 minus T1, where T2 is the time period at B point and T1 is the time period at A point. S2 is the time period at distance covered at B point, and S1 is the distance at A point. We can also plot distance time graph for the acceleration. This is the distance time graph for the uniform motion. We can also plot the distance time graph for the accelerated motion, and how we can plot it, we will see. So it's a table. This table is the table of distance traveled by a car at a regular time interval. Okay. Time interval is 2 seconds, uniform time interval, and distance is increasing. First distance gap was 1 meters, then 3, 5, 7, 9. Okay, so distance is increasing. What does it mean? It means that the car is accelerating. Time interval is same, but distance is increasing continuously. It means that the car is accelerating. And now what we have to do? We have to plot distance time graph using these values. So this is the distance type graph of previous data, and we can see that the graph is not a straight line, it's a curved graph. Okay. Graph is not a straight line, it's a curved graph. It means it is the graph of non-uniform motion. It is clear to us? Non-uniform motion. But according to data, this time interval is constant, but the distance is increasing gradually. What does it mean? It means that the car is accelerating. Car is accelerating. So this type of curve show acceleration. Okay, where speed is not uniform or the graph is not a straight line, then car must be accelerate or retarded. Okay, acceleration in positive direction or acceleration in negative direction. This curve like this show acceleration in positive direction. The distance time graph of the motion of the car, which is shown in this figure. Okay, note that the shape of graph is different from the earlier distance time graph. In earlier distance time graph, the shape was a straight line. In this curve, the shape is little bit curved. What does it mean? It means that the previous curve was of a uniform motion and this one curve is of non-uniform motion. The nature of this graph show non-linear variation. Straight line means linear, curved means non-linear. So nature of this graph shows non-linear variation of the distance traveled by the car with time. So that curve represent a non-uniform motion or a non-uniform speed. Is it clear, class? And that curve represent acceleration or retardation. If the curve is increasing, then it's acceleration. If the curve is decreasing and the curve is not a straight line, so it is a retardation. Now we will start a new type of graph, which is velocity time graph. Similar to distance time graph, in velocity time graph, time is in x-axis, velocity is in y-axis. And according to this formula, A equals to V minus U by T, velocity time graph give acceleration. Okay, velocity time graph gives acceleration. Distance time graph gives speed and give us information about is the object accelerating or not. Velocity time graph actually give acceleration. We can calculate acceleration using velocity time graph. On x-axis, we represent time in the scale of second, and in y-axis, we use velocity in the scale of meter per second. This is a velocity time graph of a uniform motion. Uniform means the velocity is not changing, but the time is increasing. So the curve is parallel to x-axis. In velocity time graph, if you get a curve parallel to x-axis, it means the object is doing uniform motion. And in distance time graph, how we get uniform motion? We get uniform motion by a straight line. So there is a huge difference in both of the cases. So we have to remember both of the cases, that in distance time graph, uniform motion is represented by a straight line, and in velocity time graph, uniform motion is represented by a line which is parallel to time axis. It means that the velocity is not changing, but the time is continuously increasing. And this area of velocity time graph, this area will give us distance. The area of velocity time graph, the area of velocity time graph gives displacement or distance. It depends from situation to situation, but generally it gives displacement. So the area of velocity time graph give displacement. The curve of velocity time graph give acceleration. Okay. The area of distance time graph does not give anything, but the curve give us information about velocity. Okay. Curve give velocity. Area does not give any quantity. But the area of velocity time graph gives displacement. Is it clear, class? Okay. If the object move at uniform velocity, the height of velocity time graph will not change with time. Height means this distance will not change with time if motion is uniform motion or the object is moving at uniform velocity. It will be a straight line parallel to x-axis or time axis. In that figure, the constant velocity was 40 km per hour. It means the object is continuously moving with a velocity of 40 km per hour and the velocity is not changing. So we will not get any type of bumps in the velocity time graph. The graph will be a straight line parallel to the time axis. We know that the product of velocity and time, what does it give? It gives displacement. So the area of velocity time graph gives displacement. Area gives displacement. The area enclosed by the velocity time graph and the time axis will be equal to magnitude of the displacement. Is it clear, class? Because the formula of velocity is displacement divided by time. So displacement is equal to velocity into time. And if we know the formula of area of rectangle, it is length into breadth, where length is in y-axis, breadth is in x-axis. Similar to velocity time graph, velocity is in y-axis, time is in x-axis. So the product of velocity and time will give you displacement. To know the distance moved by the car between time t1, okay, this is a uniform motion graph. If you want to know how much distance the car has covered between time t1 to t2, just find out the area. Okay, we know the velocity is 40 meter per second. So we can easily calculate the area of this curve, and what will it give? It give us displacement. So what will be the area? Area will be the product of 40 kilometer per hour into that time interval in kilometers or meter. This is the area of rectangle. So right now I have explained you how velocity time graph will give you displacement. Now we can also figure out about the uniform acceleration with velocity time graph. Because the curve of the velocity time graph will give you acceleration. Let us consider a car being driven along a straight road for testing its engine. You want to test a engine of a car, so you are driving it in a straight road. Suppose a person is sitting next to the driver, records its velocity after 5 seconds. A person is recording the car's velocity after 5 seconds and taking that reading through a device known as spectrometer. Speedometer? What speedometer does? It calculate the velocity. The velocity of car is in kilometer per hour as well as in meter per second at different instant, and a graph. This is the table. Okay, at 0 second the velocity is 0. At 5 second velocity is 2.5 meter per second. or 9 km per hour. We form this table. When we are going to put these data on a velocity time graph, in 0 we get the value 0, at 5 we get the value 2.5, on 10 we get the value 5, on 15 you are getting value 7.5. So you are getting a straight line curve. Okay, a straight line curve. Velocity time graph for this motion can be shown in a figure. Okay, and what is the nature of this curve? You are getting equal velocity in equal interval of time. If you check the difference between velocities, it is 2.5, and the difference between time interval is 5 seconds. So you are getting equal velocity in equal interval of time. It means the body is moving with a uniform acceleration. And the graph is a straight line. Okay, this is the graph. At 0, object was at 0. At 5 seconds, the speed of the object is 10 km per hour. So we got a straight line. It means the object, a straight line in the velocity time graph means the object is moving with a uniform acceleration. Clear, class? If we got a straight line curve in a velocity time graph, it means the object is moving with a uniform acceleration. Let's compare it with distance time. In distance time graph, straight line means velocity. In velocity time curve, straight line means constant acceleration or uniform acceleration. Okay. And this area, the area between A to E, between these two time interval 10 to 20 second will give you, this area will give you what? This area will give you displacement. Okay. And this line, this slope will give you acceleration. And how can you calculate the slope? It is calculated by using, when you will divide velocity with time, you will get acceleration. You will get acceleration. So velocity time graph gives you information about acceleration, displacement, what is the velocity at the particular time. Okay. So velocity time curve is very important for us. And you will see in next topic, equation of motion, we will derive all the equation of motion using velocity time curve. You can also determine the distance moved by the car from the velocity time curve, and how you can calculate the distance by finding the area of the curve. The area of the velocity time graph in an uniform acceleration will give you distance. If the car would have been moved with a uniform velocity, the distance traveled would be represented by the area of that ABCD graph. Okay. And what will be the area? Area, it was something like this. How can you calculate the area of this type of shape? That is a trapezoid. Okay, trapezium. Okay. Either you directly know the formula of trapezium, or you can divide trapezium into a triangle and a rectangle. And we can calculate the area of that rectangular part and that triangle part, and then we will get whole area of that we will get whole area by summing up the area of rectangle and area of triangle, and this area will give you displacement. In the case of non-uniformly accelerated, velocity time graph have any shape. In the case of non-uniform accelerated motion, velocity time graph will have any shape except straight line. Okay, velocity time graph, it's a decreasing curve. It means it has a negative acceleration because it is decreasing. Time is increasing, time is continuously increasing, but velocity is decreasing. It means this curve has negative acceleration. And what does negative acceleration called? Negative acceleration known as retardation. Negative acceleration is known as retardation. And this is a curve where time is continuously increasing. Velocity first increase, then decrease, then increase, then decrease. So it is a curve of non-uniform accelerated motion. Okay, non-uniformly accelerated motion curve look like this. Lots of straight lines. Okay, but curve is increasing, decreasing, increasing, decreasing. Clear, class? So that curve, previous one curve, shows that object was first increasing. Object velocity was first increasing. Look at this curve. Object velocity is first increasing. Then after hitting the maximum value, okay, the curve start after 6 seconds, the curve start decreasing at 10 seconds. Then it start increasing at 14 seconds. Then it start decreasing. Okay, so it's a non-uniform motion, non-uniformly accelerated motion because it's a velocity time graph. Now let's do one activity. And what does activity means? The time of arrival and the departure of the train at the three stations ABC and the distance of the station BC from station A are given in table. The time of arrival and departure of train at three station ABC and distance between B and C from A are given. And this is the table. Station A, B and C. The distance from A to A will be 0. Distance from A to B is 120. It means these are three stations. Okay. A, B, C. The distance between A and B is 120 kilometers and distance between A to C is 180 kilometers. The time of arrival, a train which arrived at A at 8 am reached B at 11:15 and reached C at 1. Okay, 13 means 1 pm. Okay, and another train which arrived at a train arrived at 8, departed from 8:15, reached at station B at 11:15, departed 11:30, reached at station C at 1, departed at 1:15. This is a table. Plot and interpret the distance time graph from the train. You have to plot this curve. Okay, you have to plot this curve. Time. Okay. versus distance curve, and you have to see the plot and try to interpret it. What will be the velocity? Is the train accelerating or not? Okay, you have to take out all these information using that curve, and you have to assume that between those two stations the speed or the velocity of the train is constant or uniform. This is activity 7.9. The next activity is 7.10. Activity 7.10 is Feroz and his sister uh, Sanya go to school on their bicycle. Both of them start at the same time from their home but take different time to reach the school. Okay. So Feroz and his sister Sanya go to school on their bicycles. Both of them start at the same time from the home but they take different time to see the school, all the way follow as the same route. Okay. And this is the graph that at 8 a.m. both were at home. At 8:05, Feroz traveled 1 kilometers. Sanya traveled 0.8 kilometer. At 8:10, Feroz traveled uh, 1.9 kilometers. Sanya 1.6. At 8:20, Feroz reached the school, and 8:25, Sanya reached the school. So it means that the distance between their home and school is 3.6 kilometer, and this is the time taken by Feroz and Sanya to reach certain distances. You have to plot the distance time graph and try to interpret their velocity, okay, their accelerations. Try to find out these. So in today's class, we have studied mainly the velocity time graph, and we learned that the slope of the velocity time curve give acceleration, and the area of the velocity time curve give you displacement. Okay. And if the graph is in increasing form, it means that the acceleration is positive. If graph is decreasing, it means the acceleration is negative. If the curve only has one straight line in increasing direction or in decreasing direction, it means the motion is uniform. If the curve has lots of straight line in increasing decreasing direction, it means that the curve or the object is doing non-uniform motion. So today we studied the topic graphical representation of motion. In next class we will learn about equation of motion. I hope this class is clear to you. Now we will meet in next class. Thank you.